Okay, good morning, good evening, good afternoon, depending on where you are. It's April 10th, and this is another hour of our bi-weekly SIG CLI meeting. My name is Mache, and I'm going to be your host today. So I have one quick announcement. During the Contributor Summit in Barcelona, during KubeCon EU, we will be hosting a face-to-face. So if you're interested in it, mark the date. We will be soon announcing the room number. Well, where this will be held, we'll have a venue where we'll be able to discuss future of SIG, of our SIG, future of kubectl. Most probably will be touch basing on the split and other topics that people will be interested in. Does anyone else have any other announcements? Sean, Phil? Okay, hearing none. Yeah, go ahead.
I don't have anything.
Okay. With that, let's move then to the test grid. So I've been on test on duty for the past 2 weeks. And thankfully, with regards to the SIG CLI, we were very stable. There were some problems with GK or GC, I can't remember, over the past 2 weeks, but that wasn't touching us. So that's good. We are very stable when it comes to kubectl tests. Quick reminder, if you're interested in holding the role for the test on call, feel free to add your name to our testing playbook. Since I haven't seen anyone interested, I've added my name for another round of testing. With that, I think we can jump off to the main topics, and we'll start with Jordan and the server-side printing, which is slowly moving to the finish line. Jordan, the floor is yours.
Yeah, I had a quick demo if you want to let me share my screen.
Sure. You should be now able to share.
All right, can you see that?
Yep.
Okay. So I have a custom resource defined, and in that custom resource, I'm using server-side printing. So I have some printer columns. This resource has a Boolean field, and I want to output that when people run kubectl get. And I have a couple instances of that. And as you can see, the custom printing is working the way I wanted it to. So that works great for get, and that worked in previous releases as well. If I run like back levels of kubectl, I get the same thing, right? But if I watched with kubectl, we're no longer just getting a list of objects. We're now getting watch events as well. And watch was not using server-side printing in previous releases. So instead of the pretty columns that I wanted, I would just get the default name and age. And if I triggered watch events in the background, we just get the default output. So we don't make use of the custom columns at all. And so as of this week, last week, we now in the 115 dev stream make use of server-side printing for watch events as well. And so what that looks like is what you would expect. Both the initial print uses the columns we want, and as events come in, they use the columns. So Clayton is working on getting this to V1, but it is V1 beta 1 now and has been for a long time. And so we can switch kubectl to using this in 115, and as of 116, we can actually remove the typed printers from kubectl entirely, which is awesome. And that's it.
Yay!
Only took 2 years.
Finally. Are there any questions with regards to the Server side printing. Okay, hearing none. In that case, let's move on to the next topic, which is Huan and moving remaining command util factory methods to their own interfaces. Huan shared with the SIG CLI mailing list an overview, a proposal for that move. I had a chance to read through it, but I'll let Huan you speak about it a little bit more.
All right, sounds great. Thanks much. So basically, Isaac is currently working on a PR that involves continuing the work we started with the REST client getter interface. Pretty much across all commands, the goal is to eventually not use the factory anymore, but instead use essentially a series of interfaces that provide essentially utilities to the clients to obtain polymorphic helpers that were available for the factory, or essentially configuration-related utilities. And so this continues that work. And so right now, the command util factory implements the REST client getter interface, but it still has methods of its own that are needed across a bunch of commands. And so the plan would be to take that remaining set of methods that are still in the command util factory, but not exposed via the REST client getter interface, and either break them up into one or more interfaces, or aggregate them all into one more interface, and either pass that along with the REST client getter to every command in place of the command util factory, or create a sort of superset interface that encompasses any other interfaces that result out of this and the REST client getter, and then pass that to every command. So either way is valid, in my opinion. Yeah, so there's an example in this document that at the bottom that shows roughly like what the intent is. Yeah, I guess if anyone has any questions, concerns, I'd love to hear them now.
I have one suggestion that I already left in the document, is that instead of having some utils interface, which is usually suggesting that this will be a grab bag for everything, I would rather have a set of targeted interfaces, and then having a superset where we would just grab all of them into one would be much more preferable approach, rather than having one grab bag with all, which would basically lead us to the same situation that we try to clean up with the REST client getter by having very narrow and targeted interfaces. So I would be leaning more towards that approach, since that will also allow higher flexibility.
Perfect. Yeah, so I definitely agree with that. And yeah, basically, I'll go ahead and modify the doc and introduce the idea of the superset interface, and maybe two or so more interfaces. Maybe we could have one for like the client for mappings and the dynamic client, and then a separate one for the OpenAPI schema and validator, since those two are related.
Yeah.
Perfect. So yeah, maybe two more, one for clients and another for that, and then encompass all three, or all three resulting interfaces in a new superset interface, which I guess name pending for that. But yeah, so a way to aggregate the REST client getter, client for mappings, and dynamic client, and OpenAPI schema related interfaces, and so also a major sort of like forcing function, I guess, behind doing this, as opposed to leaving these remaining methods in the factory would be to eventually, have these these new interfaces exist in the CLI runtime repo as well, which would make these if you want to call them utilities, available to plugins and third-party clients, along with kubectl. And I think that should be it for now.
And
Go ahead.
yeah, my additional ask on that one would be to turn this document into a cap, because at some point in time we will have to start documenting more the CLI runtime, and having the caps where we'll be having the reasoning for why we went this way or the other way in the enhancements repo will help us, and that will also allow us to follow the process that is currently required for any major work. So, just changing this document into a cap, and then, starting from there would be much more preferable, I think, given the current processes.
Sure, sounds great. So we'll turn this into a cap and mail it out to the mailing list as soon as possible.
Perfect. Does anyone else have any questions with regards to those interfaces? Okay, hearing none. We're moving like super fast through the topics. Okay, so CLI experimental repo, I'm guessing, Phil, this is yours. So want to speak about it?
Yeah, I will. Let me
Yeah, I'm going to stop sharing.
see if I can share. Sorry, I'm moving. Faces are
No worries, no worries.
full screen. There we go. All right, for some reason it's not showing up. Oh, there it is, the share button. It's the green one, of course. All right, there it is. So we created the CLI experimental repo. It exists, I think the primary function right now is to be able to look at some of the commands we've already developed and rethink if this is still the way we would design these things today, and get a chance to try out different things without committing to them and without worrying about backwards compatibility. Some of the things I'll specifically call out are with apply, for instance. We have a lot of stuff in apply. There's a lot of options there. Like you can filter what gets applied by using the -L label and different options such as this. And do we really want all of those in the apply command? Are they important things to support? Like, could we just drop them? Versus things like deletion. Like, what are some of the techniques we could use for deletion without committing to any one of them necessarily? I think one challenge we have now is there's a number of different ways of doing deletion. None of them are perfect. The server-side options are radical departures from the server architecture today, because this is a multi-resource scope, and nothing on the server-side API really addresses multi-resource scoped operations. So it doesn't fit on the server side. Most of the client-side stuff is kind of a workaround. But at the same time, not having deletion in apply is just kind of a non-starter. And so how can we work through some of our designs and try them out? This seems like a good way of doing that. We can hand it to users, try different things. Another thing I put in the repo just to try out is when we work on files from apply, we use the -F flag, and one impact of providing a flag, a repeated flag instead of arguments, is that shell globbing doesn't work well with that. And so like a lot of Unix commands, just like grep, for instance, uses command line arguments, raw command line arguments. And so like, what would it look like if we just use command line arguments and got rid of the -F flag? So trying out like different UX pieces, also trying out different architectures. What I have brought up is an alternative to factories, something called dependency injection. Go has a dependency injection framework called Wire, which uses code generation. And effectively, if you haven't done this before, some people have an aversion to dependency injection. Some people prefer only manual Wire dependency injection. What dependency injection is essentially that each component takes as struct fields or as arguments to a function its dependencies instead of initializing them themselves, right? And so effectively, your pieces become very small and focused, and they take in like pre-baked, pre-processes resources, for instance, instead of calling a library to iterate over the resources. This makes testing a lot simpler because you're now passing in like partially calculated results into functions. So you don't have to like, the scope of what you're testing is much more focused. It also allows for like some of the stuff we tried to address with the ring factory, where you can override different pieces of the dependencies. This addresses really well because you can replace any specific dependencies. So if you're like, I don't like the Kubernetes client, I'm going to swap it out for this. I don't like the way we build REST configs, I'm going to swap it out for this. You can just replace functions. So this is what I'm displaying is just kind of what dependency injection looks like. You define modular functions that build dependencies. Each one has dependencies as inputs to the function and dependencies as outputs. And the framework itself actually takes all these functions. You provided a list of functions and it looks at their inputs and outputs and then builds a graph, right? And it says, okay, I know that these nodes don't take any inputs, so they can act as sources to the things that take their outputs as inputs. And so it will wire everything together and it handles a lot of interesting stuff for you. Like it will handle, if there's an error, it handles taking care of those errors as it builds the graph. If you have teardown logic that needs to occur, it handles tearing down components after they've been initialized if there's an error or at the end of the program. So anyway, CLI experimental is where we're trying out some of these new architectures and UXs, and I have the first real core piece of functionality I have here is a PR to do the data-driven commands that I had as a branch in kubectl. But here I'm just building it out fully. So I've added I've refactored that code and put it in here, and so this will allow us to attach commands to CRDs and dynamically invoke them, potentially being upstreamed into kubectl in some form or another, or not, depending on how we feel about it after we've gotten some miles on it. That's it. Questions, comments?
Hey, Phil, can you show the part in the where the graph is kicked off, or the construction of the graph is kicked off, like in the main program?
Yeah, I can show that. So what happens is, oh, another thing I did is I put everything under internal. I put this package placeholder here. The idea is that we are going to publish libraries. When we publish libraries, we want them to be intentional and say, we're publishing this as a library, rather than, due to the way I've factored my packages, I need this to be accessible from another package, and therefore it must be public, and therefore it's exported, anyone can consume it. But I'm actually not sure about the interface, and it might change, and I might break everyone in the world, right? So delineating between, this is a package this is a public library from a package perspective for the reason we factor our packages internally, from this is something we're publishing to the world and we feel good about the interface we're providing. So I have the package directory is empty right now. The internal package, which no one can vendor or no one can access from vendoring the code, is where everything exists right now. This is a file that gets generated. And so effectively what you're seeing here is like this initialize status command. There's a status structure, and you can see it down here at the bottom. and it takes resource configs, writer for output, a client set, and optionally a git commit. The git commit's there because I thought it might be nice to be able to annotate resources with the git commit if we're pulling them out of Git, just for traceability. But anyway, so the status takes these as struct fields, and so this generated code figures out how to build them, and it does that again based on looking at what functions exist, what does the status take, and works backwards from there. So what do I need to build a status? Well, I need a commit object, so I'll build that. I need a client set object, so I'll build that, and I need a writer object.
Is there anything that's analogous to like creating a binding between a concrete class and an interface? So if my code off here accepts interface objects, and I have a choice of implementations for those interface objects, how do I make that choice? Like, or where do I make that choice?
There's the wire package provides that. So the wire package allows you to bind an object, either a function that returns a concrete type, in which case it binds that type. It knows how to access that type. You can bind a concrete type to an interface, in which case it will, when providing instances of that interface, it will go find it will create the concrete type that you bound to it. You can bind raw types directly, so you can create an instance of an object and say, just use this, don't look for a function. You can bind a struct itself, and so the struct itself will then it'll figure out how to populate the fields of that struct.
Okay.
So there's like half a dozen different things you can bind.
Great. Sounds pretty mature.
Yeah, I think it's took, the core, the solid core out of the dependency injection frameworks of the past. Like Spring and Juice are these just overpowerful things that just do a ton and are hard to reason about, I think, or many people find hard to reason about. And so this took the learnings from that and said, how do we make it look like Go? And just build a graph. So yeah, this code gets generated for you, and again, it gets generated from this right here. So there's this provider set at the top, and the provider set, you just bind different things it knows about, right? So functions and structs and other provider sets, and so you build up this graph.
Okay.
And then the magic hotness is this wire thing over here. This is code. You can see at the top, it has this build
directive
comment that like doesn't target any actual architectures. And so that's how it looks at this to figure out what it needs to build. So it says, okay, I need to be able to generate code for a status object. The writer and the resource config path will be provided as inputs. So instead of getting those from the graph, I will take those as inputs, and that's how I'll get them. And then this down here tells it which modules it's going to use to define the nodes in the graph. So again, this is code that doesn't get executed. It just gets used by the processor to generate this version of the same thing, which takes all those functions and then invokes them.
Yeah.
So it's it's an experiment. We'll see if this works well. It does some kind of cute things for you, like it checks all the error conditions all along the way and figures out how to propagates them up. So the error handling is actually a lot smaller.
Can you show also how do you provide define those providers?
Which providers? The functions?
The providers that you put into the provider set.
Those are just sure. So like,
I was just curious.
Here's an example of wiring up the K8S providers. Right, so the provider set. This is it here at line 41. It says wire new set. And so it takes these functions, right? So you can see new kubeconfig path is a function, right? I've actually changed this in a follow-up to use the CLI runtime version. This was just kind of an initial cut at it to see how it looked like with the client Go demo code. So it does something more intelligent now, but you get the idea here where this function takes no arguments. And the master flag takes no arguments, and it gets them essentially from flags that have been defined. And then the rest config takes the outputs of those as arguments into the function, and then calls a function and returns the config. The client set takes the config as an argument, which was provided by the new rest config, and then returns a client set. And so that's how you essentially build up. Instead of having a library that just provides you the client set, for instance, or instead of in your code, you invoking all those functions for each command or trying to pass around a factory that does this stuff for you, simply by defining these functions and then providing this provider set and passing those functions into the provider set, that is what causes this. This is the generated code that results from that, where it creates, calls that master flag function, calls the config path function, then calls the new rest function, checks the error, calls the client set function, checks the error.
In the development cycle, if when do you have to generate code? Like only when you're making a change to the provider set?
Yeah, or when you change anything that impacts the graph. So you add a field to this structure, right? For instance,
Okay.
you would need to. So if you just run go generate right now, it generates the thing. So it's not a huge step. I just typically run it, but
Okay.
yeah, you would need to do it if you add a field to a struct. If you add a dependency to a function, if you change a function to return an error.
Okay, so conceivably you could just put like a go generate in your IDE after every save, and it wouldn't be that expensive. It's quick enough that it doesn't matter. Just
No, it's about as long as the build time. So
isn't that big,
yeah,
depending, right?
you could do that. Yeah.
Is it integrated with Goland? Out of curiosity, is that kind of a cycle integrated already?
I don't know. I think like it could be like. I'd have to see if Goland supports to generate. If Goland supports generate, then it would be. I don't think it's integrated from the perspective of it highlights, where your bindings are missing.
Yeah, that would be nice. Okay.
The downside of this sort of thing is theirs look different than normal compile time errors. So the error is not like this line is broken. The error is typically an omission. Like, I don't know how to build this thing. Right. And so and then it will give you like a trace back, like you're trying to build this, that requires this other thing, that requires this other thing, that requires this other thing. And you haven't given me how to build that one other thing. Right.
And that's a runtime error. That's an error that somehow it's trying to make the object and it can't figure it out.
That's a code generation time error.
Oh, code gen. Okay, fine.
So when you run go generate, you will get that error before even trying to compile.
Great.
And so you just need to learn how to read that stack is the main thing, and essentially realize, hey, there's a function that should be providing this thing, and either I haven't added it to the provider set, so it exists and I just haven't added it to the provider set, or I just haven't even created the function to build that thing yet. Hopefully, no one has to screw around with this stuff that much, because the core set of dependencies most of this stuff requires isn't that large. And once we build up the main graph, additional commands and stuff will just reuse the existing dependencies that are there.
Thanks.
Yeah.
Good little DI talk.
Yeah, I know. We'll see how it works. We'll see if people like it. It's a good place to try this out, and it's a good time to try it. DI is great for designing frameworks around. So you can delegate a lot to the framework, because you're not depending on concrete things as much anymore. You can wrap, like if you use interfaces well, then you can now just do arbitrary wrapping of objects pretty easily from the framework perspective. And that allows you to do cross-cutting everything, right? Like attaching, for instance, you could easily inject something that attaches a side channel or header to all requests that are made in order to do cross-stack tracing.
Testing is easier too because you don't have to worry about testing the wiring, right? You can make a unit test for just your little components and then trust them and just be set up correctly.
Let me show you like kind of how I'm looking at testing. Again, these are empty, so there's nothing here. But the way I'm like looking at, like this is kind of the placeholder for the apply struct. And so this would be like the do function creates the apply result. And so the way I've written this is it takes the resource configs as an argument to the struct. So instead of the apply command going and like invoking the resource builder to go find all the resources and that sort of thing, you are now passing the resources directly to the apply command. And so it's acting upon those resources. So testing this should be much simpler because you don't have to fake out the
fake everything, right?
You don't have to fake anything. You just provide the resource config as an argument to the library. Same thing with like the commit. You can fake out the commit, or rather, you just provide the data directly instead of having to make the data available to a mock client or something like that. You skip that step and test that independently, the fetching of the data from the usage of it. And I also have just kind of a fake for the, or a placeholder for the test for apply. Here, this uses the new framework, which is kind of cool, I think. Actually, well, let me go back. Sorry, I'm skipping around here. Internal. So here's what tests would look like using the new framework. It just says initialize, it says wire test, initialize, apply, and then it gives you the instance of the apply struct. But this has wired in a local API server and etcd instance, so you can now go and do basically an integration test, but you have your own local etcd and API server instance, and then it provides the done function to tear it down at the end. So this doesn't really do anything except...
the done function's coming from wire?
Yeah, so wire connect. Let me show you how that looks. So if we go to the wire, so I have this wire test package. So this does the wiring for the tests. And it's almost the same, but this is kind of where you see dependency injection, its power, is they take all the other modules, right, from everything else, except getting the rest config, right? That's the one thing I don't take. And so then I just provide instead a different function called new rest config, and that calls the testing environment and calls start on the testing environment, and then provides the config that you get from start, and then provides a function called stop provides this middle function here. It's the second one, which calls stop. And so what's kind of cool here is if you look at the wire gen for this thing, it has the cleanup function here. And so if there's an error from then on out, it always calls the cleanup function. Right, so the wiring itself actually takes care of invoking all the cleanup if there's any failures along the way, which is great. You don't have to worry about that anymore. So this is the generated code, the test for generating the test instance that wires everything together and then invokes the cleanup. And then going back to the test itself, which is over here, you can see that that's what gets invoked here with the initialize apply. It gives you the test instance, and then we'll call that done function at the end. And so you can put all the logic here now, and it takes a nil resource configs, right? So the idea is in the first argument, you can just provide it the set of resource configs you would like to see applied. you can then do it. Then when you call do, you can go check and see that they were applied correctly and everything looks good.
Great.
I think we're gonna have to iterate on some of this stuff. I think like some of the, as we go further, like the scoping of the test instances or something, we're probably going to want to refine and different things like this. But otherwise, I mean, I think it's promising, and it will allow us to publish these as libraries and allow people to even override different arbitrary pieces, which I think might be interesting to them.
Yeah, I
Okay.
think one of the best things about it is it makes testing easier, and that encourages people to write tests. So that's always good.
Okay, I would like to jump to the next topic since we have one another, and then off to stand-ups. And I think that the last one will take some time. So OC auth reconcile, which is part of the kubectl independence, is problematic because a lot of the code that is part of the auth reconcile also lives inside of the core Kubernetes repo. We have Jordan on the line and Juan, who authored and reviewed the PR. The problem is that this piece of logic is somewhat problematic because we would have to duplicate that inside of a kubectl. We're not sure how far we will have to, in the future, keep the kubectl auth reconcile command. Jordan, do you remember how? Because I remember that auth was working at some point in time to have automatic reconciliation. Does this happen? Is there an automatic reconciliation going on the server side?
Yeah, so there are two ways we use this logic. One is when the API server starts up, the default policy auto reconciles. And so that's worked that way since RBAC was introduced, since 1.6. But only the default roles that are like hard-coded into the API server get reconciled that way. The other way this logic is surfaced is in the kubectl command, and that lets you run the reconcile operation on any role you want, like your own roles or bindings, not just the hard-coded ones. And it also provides additional options like tightening permissions or removing subjects. The auto reconcile on startup never ever tightens permissions or removes subjects because that could break someone. So the two things we get by surfacing it in kubectl or as a separately invocable tool is the ability to tighten, the options to tighten things, and the ability to run it on your own roles and bindings. As far as where the code lives, so there are two pieces. One is the API types that it uses. So David switched all of the logic to use external types last year in preparation for this, actually. So that's good. So we don't actually depend on any types that would be inaccessible to kubectl if kubectl was split out of Kubernetes. The main question is just where should this logic, like given a role, like what does one role cover another? How do you break a role down and tease apart like what needs to be reconciled? That logic I would expect to be split out of the API server. Like there are other tools like audit to RBAC. I have a vested interest in that one. Like it would be great to not have to vendor Kubernetes to use the RBAC library. I think having the RBAC piece in a repo that is that can be published out, so you don't have to vendor Kubernetes could make sense. It's a little more granular than a lot of the things that we've done before, but if we can demonstrate a need for it, it doesn't seem like a problem to me.
Well, the only problem, because the discussion that we've had so far were around having some library, but none of the libraries that we have, either util, Kate's utils or Kate CLI runtime, is a good fit for this. And I don't see us creating yet another one just for having those. So not kind of sure. But if you feel like you feel comfortable with this living as next to the kubectl, which, as you said, would allow Kube itself and other consumers to easily vendor a small portion, that would be a reasonable approach. For sure, not sure what the plan that Sean has, but I'll let him speak in a bit about it. I'm not sure if we will be able to completely split kubectl in 1.15, but definitely the staging repo is one of the goals that we would like to hit for 1.15. Mm-hmm. And for that, we could just then consume the auth reconcile functionality from within the kubectl repo. Even afterwards, we will still have to publish the convert as part of the kubectl. Not sure if that's still not solved yet, because kubectl convert relies on the internals, and that can't be split out in any way. And we agreed that at some point in time we will be shipping kubectl convert as a plugin. But until the deprecation clock ends ticking, we have to publish both of them at once. So you're okay with this living in the kubectl repo?
Either the kubectl repo or a repo that kubectl can use. Yeah.
Yeah. If there will be a repo, I'm pretty sure that overall the community would greatly appreciate if we had some kind of a RBAC or more Kate's utils type of a thing, although I know that people hate utils.
I mean, RBAC is a coherent piece, right? Like there's a set of evaluation functions and a set of like the reconcile operations. Like that is actually a piece that kind of hangs together pretty nicely. So I've seen people vendoring Kubernetes just to use that. I've done it. Kube control auth reconcile would need to do it.
Maybe it's a work topic for the SIG auth to bring on their table, to have a library for the entire RBAC. And then in that case, we would be more than happy to give that piece over to that library, and then we would just consume that piece in the kubectl.
Yeah, let me throw something on the SIG auth agenda. I think we can split that out for you.
Oh, that would be awesome. So for that case, we could probably then continue with this as not a copy, but as a move over to kubectl, and then as the situation will be clearing up, we'll be moving this back and forth as needed. Does that sound okay to you, Jordan?
Moving it to kubectl. I think, actually, let me start a mailing list topic so we can get an answer ahead of the meeting next week, just so we have a direction.
Sure.
And I think having an RBAC piece, and then having kube control use that would be what I would expect. So let me start that. I'll copy SIG CLI and that
would be the best. Cool. Thanks very much. Okay. So one less off the list, and let's switch to stand-ups, and I'm gonna give the floor to Sean to talk a little bit more about the kubectl independence.
Okay, yeah, that's a great transition. So I believe we have basically three PRs, if you want to call them that, three areas left. We already know about convert. That convert, we deprecated back in November in 1.13, and as you mentioned, we're waiting for that clock to run out in 1.17. We're probably going to provide a plugin so that functionality will be available afterwards. It'll be just slightly more difficult to, you'd need to download it or somehow distribute that. So that's one piece of functionality. The next is the one that you just finished talking about with the RBAC auth reconcile dependency. And the final one is one that I've put out a PR on and incorrectly copied one part, the human readable.go into kubectl. That, as Jordan pointed out, at least parts of that should go into CLI runtime and under package printers, especially the print table, the stuff that is being consumed under registry, under the storage.goes. That part should be in a common repo, which will be the CLI runtime. And once that part happens, then the remaining dependencies that are in get, it's depending on internal types. We can, in a relatively straightforward manner, just change those to external types. I've already had that working. And as Jordan points out, also, we're able to get rid of those types because of server-side printing is being completed. We can get rid of those types altogether in 1.16. So actually, I believe we are, very, very close to being able to get kubectl out. So I'm also have two KEPs in progress related to this. So initially there was one KEP talking about how we were going to move kubectl out. I talked to SIG testing. I've talked to other people, and it started appearing that it was quite a big, going to be quite a big process. It's going to require a lot of buy-in especially from SIG release and SIG testing. Just to overview what we plan on doing for kubectl independence is we plan on putting packaged kubectl into staging, copying that into our kubectl repo, and copying kubectl main into this new repo. So we would, in essence, be building the exact same kubectl binary in two different places, which would allow us to incrementally move the tooling over to this new repo. And basically, we wouldn't have to cut over until we were completely happy and had very good confidence that the new repo was working as good or better than the previous repo, and everybody would be ready for it. But that particular KEP seemed pretty big, and we actually have consumers now who want to consume apply-like functionality, and so Phil has suggested that I break off a smaller KEP of just moving kubectl into package kubectl into staging, and just have that as a smaller KEP. And I should have that KEP out relatively quickly. Yeah, if anybody wants to comment on that and what we think about those KEPs and where we stand, that's kind of my big long spiel. Does anybody want to comment, or is there any feedback on where we're at and the direction that we're going?
Sean, can you send both of the KEPs over to the SIG mailing list so that we have a broader distribution of the topic?
Yeah, I definitely. So I haven't completed either of those KEPs, and so that's why you haven't seen them. It's not that
even all the way back to the kube dev so that we have a wider distribution of it in the first place. Second
Right.
of all, yeah, definitely moving as a starting point, moving package kubectl over to staging will, aside from the fact that we will be able to publish kubectl as a separate repo over to kubectl, is one important goal that I would like to achieve in 115. And second of all, the fact that we move it over to the staging repo will ensure that we can put in place proper import restrictions so that nobody, even in a very hacky way, won't be able to break the work that we put together into the split. Even though it will live as part of the staging repo, the fact that it is split out into that staging is a very good guard against anyone introducing any unwanted dependencies. And yet at the same time, this allows us to get the clock ticking for the convert command that we just have to switch over to a plugin at some point in time.
Yeah, so I was thinking, it's going to require time for both convert and for the auth reconcile, but we could actually move most of this into staging without moving those parts that are still problematic.
That's not quite true. So
Okay.
things in staging can't depend on things outside of staging.
Right. So that's
the internal types are in Kubernetes, not inside staging.
Right. So that's actually what
yeah.
I meant was we would copy package kubectl everything except the convert and the auth reconcile pieces into staging. Does that clear things up, Jordan?
Yeah, that will work.
But the main command would still live inside command kubectl, not under staging.
It will have to be.
Okay.
Correct.
It will have to be. We will be building the main command still in the Kubernetes repo. We would have a copy of the main in the kubectl repo just to be able to build it over there.
Without convert and reconcile.
Exactly. That will be the only difference between the two.
That's interesting.
I need to sync. I'll have to sync with Stefan with regards to the publishing bot, how that handles changes that are lying in the repo next to the stuff that are being extracted out of the staging. How much possible is that, so that we have the base, which is being extracted out of staging, and some command main for kubectl inside of a kubectl repo. Also, let's not forget that there are some stuff in the kubectl repo that some people are relying on. It will be good to deprecate those, but we will have to copy them over to the staging repo just to let the people drop those in favor of the internals that we provide.
Really? Wait, so we're going to be importing things to Kubernetes staging repo from the old kubectl repo clone?
Yeah. No. We will copy some stuff. I know that there are people that are consuming current kubectl repo. I can't remember which parts, but there are some parts that are not living in package kubectl, but are in the kubectl repo, and there are people consuming those. I want to ensure that we don't break anyone in a very bad way. We'll just deprecate those and bring them over the package kubectl inside of the staging repo, so that we have clean, because aside from the main, the book will also live in the current kubectl repo as is without touching it.
Okay. Yeah. So just as a,
it's not a simple move. It will take some time, but we'll get it slowly. But we will get it.
Yep.
Okay. Any other closing remarks before we wrap this up? Okay, thank you very much. See you in 2 weeks in that case. Bye, folks.